Hi, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. In this clip, we are focused on particles and waves, and we're looking at interference. Here's an exam question. Two waves are said to be in phase when 1, peaks and troughs match, 2, they combine to form a zero amplitude wave, or 3, they have the same wavelength. And then we get a variety of options. So we're going to read the question closely and pick out the things we're being asked about. This is about waves and when they're in phase, obviously. Look at the options, see if there's anything obvious to ignore. Well, nothing obvious because they're just a combination of the options given. Recall that this is in the particles and wave part of the course, and read the question again slowly in your head to make sure you've read every word correctly. Avoid overcomplicating and getting lost. If your brain has gone to mush, just stop, take a moment and try reading it again. So we're looking at waves here. There is, however, a sense of just being able to work this out from the term in phase, the opposite being out of phase. And this makes it very tempting to say that it's likely that peaks and troughs match. In a very scientific sense, in phase feels like matching. Now, recall knowledge would let us know that if we combine two in-phase waves, they don't cancel each other out. And again, in a very non-science point of view, if the peaks and troughs match, they have to conclude the waves are likely going to have to be the same wavelength. So here we have the two examples, and we can see here that for things to be in phase, the peaks and the troughs should match each other, but also the wavelengths should be the same, otherwise the peaks and troughs wouldn't match. Here we can see things look out of phase. The peak is matched with a trough. So that doesn't look like in phase. So that will all help us answer. So that lets us determine the answer. Two waves are said to be in phase when peaks and troughs match. Well, we can see that peaks, we know the peaks match, and we know the troughs match when they're in phase, so that's correct. They combine to form a zero amplitude wave. Well, we know that if we combine these two, we should get a bigger peak and trough, the combination of both of them. So that's not true. And 3, they have the same wavelength. Well, we know that if the peaks and troughs are going to match, then the wavelengths are going to have to be the same as well. So that leads to one conclusion, that the correct answer is E. Statements I and I are correct. Key things to note here. Well, we're recalling from the course material the definitions, and I don't usually advocate this because common sense is the death knell of any exam question, but in and out of phase probably do suggest a matching and a non-matching wave. However, that should also be easy. As always, here are some other examples to try, and the answers are on the Hi page, hihy.page/physics FYSX. Thanks for watching.